Hey guys, my name is Hamid, and in this short tutorial I want to explain to you the code, the expressions for inertial bounce. Maybe many of you use this inertial bounce expression without knowing what exactly this do and what step by step this code is. So I made this code something somehow simpler for you, so you can understand it, and I will explain it line by line, so you can create your own inertial bounce. So for that reason, I have a simple scene here. As you can see, it's just a box, and if I let it play, it moves from one side to the other side and it stops here. So we want to create some expression for this to have some inertial bounce. The first step, as you know, hold Alt and click on the slide, so you can type here. Okay, make some room here for typing. The first thing that we should have is to define two variables for our work. The first is n and 0, and the second is t. N is for number, the keyframe, which keyframe we are right now on, and t is for our time delta. Okay, let it be 0. So the first step. Before we begin, I should explain to you what we have to write right now. Okay, it's right. Okay, because we didn't have we can here write something. For example, value. So it's right now. Okay. When you write value, it means that it will read these numbers. Okay. So right now, what the first step is to know when our time indicator passed our second key. I mean, from here to here, we don't have any inertial bounce. The inertial bounce will begin from this time, when the time indicator passed our second keyframe. So we should create some simple expression for knowing that when our time indicator passed this second keyframe. So it's very easy to write something like this. The first thing, if I write an if parentheses num keys. Num keys is a constant that gives you the number of keys. For example, we have here 2 keys, so the num key is always 2. If num keys is greater than 0, that means if we have any num keys, if there is no num keys, if there is no keys, so it will not work. This inertial bounce works only if you have at least 2 keys. So if the num keys is greater than 0, so this is our first if that will work. Okay, so if we have some keyframes, that means if we have any keyframes, we should work. Here, okay, we have declared here this n, so we use it here right now. And equal nearest key. What is nearest key? Nearest key, for nearest key, wait, index. So right now I have to explain this. What is actually nearest key? It means it depends on our time. So you see, we have one input parameters. It's our time. Time is where our time indicator is. So the nearest key tell us, for example, if the time indicator is here, If the time indicator is here, the nearest key is this key. If the time indicator is here, still the nearest key is this one. If the time indicator is here, the nearest key is this. If the time indicator is even here, the nearest key is this one. So we have this nearest key function depend of time. It means where the time indicator is, give you the key. So, but we don't want to have the value of the key, but we want to have the index of the key. The index of the first is, of course, 1. The index of the second of your second key is 2. If you have any other keys, it will be 3 or 4, 3. So with this end, we just right now we want to just know which key frame it is right now. If it's the first key frame, so as I told you before, our work begins after the time indicator passed the second key. So if it's the first key frame, so we have nothing to do. So okay, so we n, if parentheses n was greater than 1, then okay. What that means? It means if this n is greater than 1. If it's 1, that means this one. So we have nothing to do with it. If it's greater than 1, if it's 1, so we have nothing to do with it. So what to do? Else okay, and equal 0. So if it's 1, if it's this key frame, so it will, our n value will go back to 0. But if it's not this key frame, if it's 2, so we have here 2 different situations. If our time indicator is here, the n is 2, but our work will not begin yet because we are before the key frame. So we should know when we pass the second key frame. So if the n is greater than 1, it means that we are somewhere here. But we should get sure that we are not in this area. So we have another if. If 1 is greater than, if n is greater than 1, so I said if there is another if key dot n, this means this current key dot time is greater than time. Tricky. N equals 0. What that means? It means if we are sure that we pass the first key frame and we are here in this area, if the key n, that means key 2, this key, that time, we have a time for this key value, is greater than time than our time indicator, it means that we are somewhere here, right? So if we are somewhere here, still the n will be 0. So the n will be 0 from begin until here with these 2 if. Simple, huh? But our work has not yet begun. So until now we are sure that we have passed the second key frame and we can start our work. So If n is not 0, why? Because if n is 0, that means we have to do nothing. If n is not 0, so what to do if n is not 0? We calculate here the time delta. We have a t here that is right now 0. T equals time. That means time is a variable, as a main variable for giving out the time of the time indicator. Time minus t and time. So here we get the delta. It means t time, this time minus our time indicator. So in every frame it is something different. If we are here, it's more, it's less. If we go more forward, it's less because time. It's more because time minus time delta. So that is our time delta. So we have to know how many frames we passed. So with this code, we have to know how many frames we passed the second keyframe, because we should have the inertial bounce begin from here and go forward. But the last and the main part of the function, if n is greater than 0. So until now, all of this was preparation. Okay, we needed something for to know where our time indicator is and the time delta. So we have all the information that we want, so we can right now begin our expression. So if n, you see here in these two cases, n get back to 0, and in the first line we have n to 0. So if it's not these two cases, if the time indicator passed the second one, that means if n is greater than 0, we have all what we want, and right now we can begin to write our code. Or we can say, we can write here an else, and put this value here. That's the right place for this value. It means if n is 0, stay on the value what we have as keyframe. But if it's not 0, we should come here. The first thing is to create a variable for our velocity. So v equal velocity at time. This is a function, and a function that we have in this function one input. So we want to know the velocity of the t parentheses n. So we get here enter time. Okay. So here in this code, we get the velocity of the second keyframe. So after we get our velocity, we should write our main code. Value, the main value of our keyframe, equal value plus plus map that is t, our time delta. So easy. and we are done. So we are done, and we are not still done. You should see what we have right now. So let's play this to know what we have. You see, it's not too much. It's not too much because we have to put the velocity here, you know. There is no velocity, so there is nothing to change. So I put here value plus velocity and play it again. You can see it right now. As you can see here, we have a wave here, but it's a very big wave, and it didn't end. I mean, you see. So how to okay, we have a wave. That's a good one. But how to control this wave? And this wave must go less and less and less. So how to do this? Okay, very, very simple. The first thing is that we need to define another variable for this to have control over two things. One of them is our amplitude, and another is frequency. At first, I want to have a control about my amplitude, so I create an AMP for amplitude variable equal this. Okay, and I put it here. Amp. So right now I have, as you see, the amplitude is less, but you see the frequency, the amplitude is good, I think, but the frequency is very low, because right now we have no control over our frequency. So easy to have control over frequency. I will create another variable, frequency equal, for example, 10. I have to see. But for applying this, it must come here for sinus. It means multiply our t. T multiply frequency. So we should know what we have. Wow, that is it. So we are not at the end, I think. But we have right now just one simple problem, and it's that we have right now no decay. So how to get the decay? So how to get it slower and slower until it stops. So for this, we have to create another variable. So I name it, decay. I name it decay and equal, for example, 3. So 3. And here I use math dot exponential decay multiply t. This math exponential is a function for having an exponential curve. As you will see here, this is an exponential curve. In mathematics, I hope that you are familiar with it. So we have a low value, and very soon it gets high too. So we use this math like exponential, but I don't know, maybe something is wrong here. Okay, it will work, and we check it again. Wow, we did it. You see? So you can after this play with the amplitude, the frequency, and your decay, and to have your own values. But that's a simple That's the simplest way to have an inertial bounce. But if you have more interest, there is an advanced code that I was inspired from this actually. You can see it here in the swinging kinetic text expression for After Effects. But the main, the steps are the same. The main thing is it's the same. So I hope that it was easy for you and I could explain to you everything step by step, and you can create it by your own after this, and you enjoyed this tutorial. So thank you for watching, and don't forget to subscribe.